Chip in 7 years is almost his.
A retired fighter, quite cool. Fighting from the distance, looking for the stop. Not wanting to
All of these games are structured worlds with well-defined rules. Each involves strategies and potential payoffs. When we put money on games, the outcome affects us. Therefore, we care about the odds. The understanding of odds or chance leads to probability theory. The founding father of this subject had a serious stake in understanding the outcome of a game of dice. Cardano was an Italian mathematician with a well-known gambling addiction. He wrote letters in which he bragged about his ability to beat his friends. His trick was to place his bets using his ideas from mathematics. His breakthrough was a method of calculating the certainty or probability of some random event, such as rolling snake eyes. Let's pause for a moment and think about the physics of dice. There are two reasons why a dice roll is unpredictable or random. The first is symmetry. Dice are designed to be symmetrical, unlike an egg, which is asymmetrical, always falling predictably onto its broad side. Dice are balanced so they do not favor a side. The second is mixture. Each time we roll a dice, tiny changes in the initial position and velocity of the dice are amplified as it bounces along its path. The unpredictability comes from not knowing the exact initial speed, position, and direction of the toss. This results in a powerful property Cardano noticed. Every outcome is equally likely. This allowed him to calculate the probability by developing what's now called a probability space. First, he counts all the possible outcomes. Then he defines the event in question, such as rolling a 1, which can occur in one way. The probability is then found by dividing the event by all possible events, which in this case works out to 1/6. Realize the cold calculating logic here. There is no such thing as a lucky number, no divine intervention. The probability of rolling any number is exactly 1/6. The same logic applies when we roll multiple dice. Imagine he needed to know the probability of rolling a pair, such as snake eyes. First, he counts the size of the sample space. With 2 dice rolls, there are 36 possible outcomes. 6 times 6. Then he counts the number of ways you can roll a pair. There are 6 different pairs. So, 6 divided by 36 is the probability of rolling a pair. Also, 1/6. This simple yet powerful idea allowed Cardano to bet according to the true odds, while his opponents placed their bets based on hunches and lucky numbers. Remember, this works with multiple tosses. Imagine we needed to know the odds of rolling 3 1s. Simple. First, we figure out the size of the sample space. For 3 dice, this is 6 times 6 times 6, or 216. There is only one way to roll 3 1s, so the probability is 1 divided by 216. This was the trick. It was not based on magic, but mathematics. Years later, 2 more Italians, Pascal and Fermat, refined Cardano's idea while they were pondering the outcome of sequences of random events, such as multiple coin flips. Consider the following. Imagine 2 rooms. Inside each room is a switch. In one room, there is a man who flips his switch according to a coin flip. If he lands heads, the switch is on. Tails, the switch is off. In the other room, a woman switches her light based on a blind guess. She tries to simulate randomness without a coin. Then we start a clock. And they make each switch in unison. Now, the interesting question. Can you determine which light bulb is being switched by a coin flip? The answer is yes. But how? The first step is to keep track of each sequence of events. 1 equals on, 0 equals off. The trick is to think about the properties of each sequence, rather than looking for specific patterns. First, we may try to count the number of 1s and 0s in each sequence. This is close, but not enough since they will both seem fairly even. The answer is to count sequences of numbers, such as runs of 3 consecutive switches. A true random sequence will be equally likely to contain every sequence of any length. This is called the frequency stability property, and is demonstrated by this uniform-looking graph. The forgery now is obvious. Humans favor certain sequences when they make guesses, resulting in uneven patterns such as we see here. One reason this happens is because we make the mistake of thinking certain outcomes are less random than others. But realize, there is no such thing as a lucky number, and no such thing as a lucky sequence. If we flip a coin 10 times, it is equally likely to come up all heads, all tails, or any other sequence you can think of.